Hello, my name is Jordi Ricard, and it's a pleasure to introduce the 8th session of our Journey to the Cloud series. I will start with a quick introduction about synvert and hand over to my colleague Victor to present this series of webinars where we want to address the different technologies available to build data platforms on the cloud. Today, we will focus on Databricks, but you will find online the previous sessions we did before. After that, Alex and Tobias will take us through real project examples where we use Databricks and how reusable those components would be to accelerate your data platforms leveraging all the benefits of Databricks. We are part of the synvert group with 5 other leading companies across Europe with more than 20 years in the sector, with the ambition to become the largest full-service data and analytics consultancy group in Europe, with over 500 consultants in our offices distributed in Spain, Germany, UK, Switzerland, Croatia, Middle East, and US. We are experts in everything related to data, supporting corporations across multiple verticals with high-quality deliverables and honest and transparent partnership with our customers that usually make us proud of the length of our engagements. We can help from business intelligence and executive reporting solutions for making better business decisions and empower digital transformation and data-driven culture to your enterprise through all the technical design of cloud architectures and the data management and data engineering projects to partner with you on the data journey to support your business. Our references creating data applications, implementing data science and machine learning use cases across different industries, empowering and defining data governance strategies, or evolving data platforms to big data environments across the leading technology in the market makes us feel comfortable and ready to help in your data challenges. At synvert, we are proud of being Databricks partner, and we've been actively publishing content around this technology in several forums, as you can see on your screen. But beyond the technical skills with Databricks on the main hyperscalers, we are very proud of the concept of accelerators that allow us to quickly leverage the innovation from project to project and accelerate the time to market and implementation of our projects like the data loader and the ETL framework you will see today. With that, it's my pleasure to hand over the session to Victor Colomer, who will continue with the highlights of the series of webinars.
Okay, so thank you, Jordi. I'm going to do the introduction of the series. Basically, this has been a long journey since we started this Journey to the Cloud series. Everything started with Azure, and since then we have been delivering webinars for all the key technologies that we believe you should consider for building a lake-hosted platform. Additionally, in line with what we are seeing in this webinar series, we have also delivered a very interesting blog series where we discuss the features of a data platform that we think it should cover. We encourage all the viewers to read those blogs too. But basically, in this webinar series, we have already covered Azure, Google Cloud, AWS, Dremio, Cloudera, Snowflake, and Oracle. And today marks the finale of our series, and we are thrilled to spotlight Databricks. We'll begin this session with an overview of the Databricks platform itself, followed by the introduction of a data loader that we can develop to accelerate data ingestion into Databricks. And finally, we'll share a real-world example of its application in a customer project. So, about Databricks. Databricks is a cloud-based data platform that integrates data engineering, machine learning, and business intelligence within a unified lakehouse architecture. It is designed to support the full data lifecycle from ingestion to visualization, enabling collaboration among data professionals. Databricks combines data lake as a unified storage and basically the best Spark that you can get in the market to provide an unrivaled ETL experience. It provides a unified governance layer across data and AI with the Unity catalog that provides fine-grained access and data lineage and audit capabilities. And on top of it, there's the data intelligence engine, which is the whole thing that gives the data intelligence platform name, which basically they are using generative AI to understand the semantics of your data to improve the governance of your own data, and also providing other features like an AI assistant that speeds up the development. Databricks also stands out in the data science field with their native MLflow integration that accelerates the delivery of machine learning and AI models. Additionally, they provide this Delta Life Tables capability that enables batch and streaming processing with automated data quality, workflows for auto-scalable job orchestration, and the SQL warehouses that are visually specialized compute cluster for BI use cases with the text to SQL capability included. So I don't want to explain more about Databricks. Now, as I mentioned before, my colleague Alex is going to present the data loader that we have developed after many years of working with Databricks to ingest data, and we hope you enjoy it. So Alex, the floor is yours.
So thank you, Victor. We will now have a look at the generic data loader, and it is a generic metadata-driven ETL framework on Databricks to accelerate your journey to the cloud. So let me introduce, first of all, the challenges and objectives. As you may know, many businesses have vast amounts of data from diverse source systems, and they call for a unified storage approach for extracting insights from this data. With the amount of data increasing, ingestion and processing of this source data can be very challenging and lead to complicated ETL pipelines that are difficult to maintain and scale efficiently. Because this is such a recurrent task, we decided to tackle this problem once and for all by designing a sophisticated ETL framework with the following characteristics. First of all, it's generic and metadata driven. This means it uses metadata to keep the development and maintenance efforts low and use a parameterized approach wherever possible. This means we only need to adapt the metadata if we want to implement new loading jobs. Our metadata framework is consistent from ingestion over transformation to delivery, and every job is logged for traceability, analysis, and reconciliation. Next, our framework is modular and extensible. Our data loader already handles multiple different source formats, but if something is missing for your specific use case, its functionality can easily be extended thanks to the modular design. Scalability. Leveraging the power of Spark, our solution ensures scalability to manage even the largest data sets without compromising performance, catering to evolving business needs. Automation. With a focus on automation, every aspect of our solution is designed to operate seamlessly, reducing operational overhead and enhancing efficiency. Here's a look at the high-level architecture of our metadata framework and our ETL framework. As you can see, everything is centered around the central Databricks component. Although shown for Azure in this specific slide, we can easily adapt this for other cloud providers, so we are actually cloud independent. On the left, you see the different ingest streams that we have. Currently, we support CSV files, XML files, JSON files, but also batch reads from Kafka streams. Files are put on a storage first before they are ingested with Databricks, and everything inside Databricks lives as SQL tables in the data lake format stored on a storage account. This also holds true for the metadata. For the scheduling, we are using Airflow to allow for more complex scheduling options than Databricks brings. In the end, data can be accessed by Power BI Databricks connectors, or we can push data directly to the target systems like in SAP HANA, or also via file. Everything you see here is also integrated with CI/CD processes and pipelines. So we have one repository for all the infrastructure as code setup to actually deploy the cloud resources. And then we have another DevOps repository that allows to fill the actual transformation logic and everything that lives inside of Databricks. Going into the Databricks architecture of the data warehouse, we see that we have a classic multi-layer design of our data warehouse. At the bottom, you see the ingestion from source system into temporary staging area, where data is first validated. Then it's versioned and historized into the global staging area before the business logic can actually take care of extracting and enriching data to get insights. At the end, data is further refined into data marts or in the output layer in case you want to deliver data to a target system. So let's now have a look at the data loader part of the ETL framework. So in the beginning, you have a CSV file or a JSON file, XML file, or data from Kafka that you want to ingest. And in case of files, they are landing on a storage account that is watched by our Airflow scheduler. The Airflow scheduler then starts a Databricks process to ingest this data. And it's first loaded to the temporary staging area while performing some checks like data type checks, duplicate detections, or schema validations. In case there are any errors, those rows are written to an error table together with some error information, so you can later analyze what went wrong. In case no errors appear, data is written to the GSA while being historized with the slowly changing dimensions type 2, so adding a few technical columns like timestamps and active or deleted flags. The whole framework here is as well modular and extensible. So if you want to add different sources like direct reads from databases or batch reads from event hubs, you can easily add this in the first stage where the TSA is loaded. For the data transformation part of our framework, this is as well modular and generic and controlled by metadata. So here we really tried to implement this with best practices from classical software development. So everything is put in reusable functions that then can be combined to make up jobs which perform your actual business transformations. On top of that, there's our framework sitting, which also provides a test framework and a live mode. So you can have unit tests together with your ETL pipelines implemented very easily. Again, error handling is part of this framework as well. So errorless rows can be written to error tables and can automatically be reloaded in the next run. For example, if some reference data is missing and a join fails for some rows, they are written to an error table and will be reloaded the next time this job runs to see if with new reference data, this may succeed. Also, all job runs are logged in the metadata tables as well. So stuff like the start and end time, the status, statistics, and so on for later analysis and reconciliation. Next up will be a live demo of what I just explained for the generic data loader. Okay, so now we are inside of Databricks to show you the generic data loader demo. First of all, our basic metadata layout looks like this, that we have some table where the jobs are configured. So for this example, we have two different jobs, one for reference data and one for dependent data that depends on this reference data. Both of those have an entry in the ETL job table together with an ID, their name, some smaller description, and also the sequence call. So the sequence call is basically the part of the framework that will be called when this job is executed. For our example, we will have the GSA load, which is our sequence for the generic data loader. If you run one of those jobs, they take the metadata as parameters from the ETL job parameter table to actually control what their job is doing. So in here, we have different parameters, as you can see, like, for example, the file name pattern that the input file is named, the file type that is read, the encoding, field quotes, field delimiters in the CSV file, and so on. All of this information is also conveniently stored in a JSON file, so the job config can be read from this JSON file to be processed more easily than to be looked up from the table each time the job runs. So as you can see here in this file, every required data is also gathered, like, again, the file name pattern, but also things like the error table name or the source and target table names. For the data loading, we start off in this demo with an empty table for the reference data. And we want to load a file that I prepared with just some small amount of data. As you can see here, this reference table has some technical fields for historization. And then the actual data fields are down here. We have the country code, the currency code, and the country. And this file provides now some example data with a country code in 2 letters, a currency code, and some description. Now we can run a job by just passing it 2 parameters. We only need the job name, which is in case load reference, and a file name that we want to process, named the reference file with the 1 at the end. Normally, this data would be provided by our scheduling tool, but in here, I will now execute this on my own. Once this job has finished, the result of the table will look like this. So again, you have first your technical columns. So we have just performed our very first job run. So this is why this ID job run is 1. It has no updates on the rows. Then we have a unique ID on our columns, on our rows. We also have an active and deleted flag indicating that this is the currently active value for this row, for this business key. And then you can see down here our timestamps when the data was first loaded and until what is valid. Since there has been no update yet, the valid 2 is set to the year 9999. Also, you can find the data in here just like it was in the file. Now, as you might have noticed, there was a mistake in there because we have the country code 80 standing for Austria, but the country description in here is Australia. So how can we do an update for that? Well, in the next file, we actually have 3 lines. First, we correct our entry for Austria. Then we have a new entry with the correct values for Australia. And then we add another row, a completely new row for Zimbabwe. If we load this data with our generic data loader, again, only passing the job name and the file name, it will do historization based on the business key that we have set in the configuration and the metadata. And this is based here on just on the country code, so on the 2-letter country code. After the load, if we look at the data again, you can see that you now have new data coming in below with this ID 2. And you can also see that we have an update up here with the ID 2. And this is actually our line from before, where we have the wrong combination of the country code 80 and the country Australia. New data is inserted down here. Again, this is now set as active. And this updated row is marked as inactive because for the country code 80, there's a newer version available. You also find this in the timestamp that now this timestamp is set to be valid until this specific time where the second row has been loaded down here. Let's load another file. And now we want to do a full load, meaning we want to delete rows that are not present in the new file delivery. This is something that can be set dynamic by also introducing an additional column set to initial within the file. So your source system can deliver or can decide on its own if it's a delta load or a full load by just including this additional column with the initial. Now everything that is not included in here based on the key, that will be deleted from our database, but instead of doing actual deletes, we are of course only doing soft deletes, so no data is actually lost and we are just marking the data as deleted. As you might see, there is this line about Zimbabwe is now missing from our data. So what happens if we perform this load and look at the data again? Everything that is included will just stay active as it is. And also there are no updates in here. So nothing is updated. And only this line about Zimbabwe now has an updated flag set to 3. And you will see that is now set to inactive. We also introduce one additional line. So to differentiate between updates and deletes, we will have an additional line that is set to active and with a deleted flag equal to 1, which reflects this line of Zimbabwe. Why are we doing this? Well, if you now think, okay, we want to reintroduce this Zimbabwe line, we have a new file, now again as delta load because it's missing the initial. Again with the currency for Zimbabwe, and we load this, then we will have another row that says, that gives the new data with an inserted ID of 4. And also the line before that said, okay, Zimbabwe was actually deleted. This will be set to inactive. So we are basically reviving this record, but because we are using slowly changing dimensions type 2, each row can only be updated once to have a consistent view of your data. Now let's switch over to some error handling. And for this, we load the other example with the dependent data. So there, our data looks like that. We have some transaction ID, some transaction code. Then we have a country, we have some date, and we have some amount of a transaction. And in here, the first row, this transaction ID is the actual business key. Now, if we load this data and look at it, you can see, just like before, data is loaded into our GSA because it's the first load. There's no updates and so on. Just everything is loaded as is into our table. Now let's look at it. What happens if we enter some wrong values? For example, let's take this transaction for Germany and put an invalid date. So here we have the 31st of February 2024, which of course does not exist. And if we try to load this row, we will get an error. The row will not be inserted into our database, so this data is unchanged. Instead, we have our error table, which indicates the row that we read, together with some type error in the error map, directly telling you that this value is not a valid date. Let's look at other errors that are detected by our framework. For example, if the transaction ID is missing, like in the first line, the transaction ID is set to not nullable in the database and is actually our key column that we are performing historization on. Or if you look at the second column, where we have a varchar definition with only 2 characters, and this is an entry that would be too long for this column. Now, if we run a load of this file, we again have no change in our actual database because those are regarded as errors. And we have now again entries in our error table saying that this line has a problem because the length error of the country code, this entry is too long. Okay. This concludes the demo of our generic data loader. I hope you can take away something for your project, and I will now hand over to Tobias for the next part of our webinar.
Yeah, thanks, Alex, for the introduction to our generic data loader. Now we come to my part of the presentation, which is about another use case for this generic data loader. It is a reporting data warehouse, mainly for asset management, but not exclusively. So why did we choose this generic data loader as the framework for our project? When starting working on this project, we had 4 framework requirements that were basically set in stone. One was individual data pipelines. We wanted to create individual data pipelines for a lot of data and a lot of different files, and to use business rules and data quality checks for validation during the transformations. And we also had a specific data model in mind that we needed to cater to our needs. Then the second point is it should be with a high level of scalability and automation. And this is covered by this framework excellently because of its metadata-driven onboarding process, where we just have to adjust the metadata and can easily onboard new files and new data. Then from the beginning, we knew that we have at least 3 different file formats that we wanted to onboard. These were CSV files, XML files, and JSON files. And since this framework is running on Spark, it was really easy to onboard these features. Then the last part is data governance. Because we have a lot of users working on the data in different areas and on different workspaces, it was really important to have a strict data governance feature here. And this is handled in Databricks Unity Catalog, which makes it really easy to onboard into the Azure identity with role-based access. With the whole architecture, we basically follow the medallion architecture, which is depicted here. On the left side, we have the data input, which can be either batch data or streaming data. And this data is then onboarded to the 3 layers, first to the bronze layer, then with increased data quality for each layer, we have then the bronze layer, silver layer, and gold layer. And then on the right side, the output into the consumption layer, which is for us mainly Power BI, and in the future, possibly machine learning. In the bronze layer, we have basically raw data, which is just as the files come, and we apply a schema to those files and just handle basic errors like duplicates and missing keys and so on. Then from bronze layer to silver layer, we filter the data, we clean the data, and we apply a common structure so that it's easy to prepare the data for the consumption in the gold layer. And then in the gold layer itself, the data can look very specific to the needs of the actual consumer, which can be like high-level business aggregates for business intelligence, or some aggregated tables that are for a specific machine learning use case. You probably remember the slide that Alex showed before. So this is basically the same slide, but with our architecture applied to it. On the first glance, it looks really similar, but we have made some major changes here. So the first thing you probably notice is that we have 2 data marts, one for analytical data loads and one for reporting data loads. We call it analytical ready data mart and reporting ready data mart. Another thing here is that we have here on the left the data access, which is really different from what Alex showed you. We can have data access to all of our layers, basically bronze layer down here, silver layer in the middle, and the gold layer in the data marts. Because data scientists might need different data than we need for the Power BI reports. And so it was really important to have access to all the layers here. Then another thing here is the arrow on the right, which indicates that we can have silver to silver layer transformation. This basically says that we can mangle data and work with data inside the silver layer to better prepare it for the right use case. This next slide is about the governance in the Unity catalog. As I said before, it is a really important point for us. And we came up with this Unity catalog setup. We have basically one Unity catalog metastore that is company-wide that governs all the sub-products. So for example, the project Alex is working on is one product, and the project I'm working on is another product. And this Unity catalog metastore is company-wide and governing on the one side Alex's project and my project. Then for each of the products, we have on the one hand non-productive workspaces and production workspaces, and to strictly separate productive and non-productive work. What we can do now to allow access is to create what is so-called bindings, which allow users from one product to have access to data from another product. And this results in still having high security standards while being able to easily share data across products. In our front end, we are using Power BI, and I've brought 3 screenshots for you to have a look at. So this first one is the summary page, which is the initial landing page a user opens when looking at the dashboard. Here on the top, we have a date picker and multiple drop-down menus for doing drill downs. In the middle, we have information such as the market value change for portfolios over time. And here on the bottom, you can see the market value change for different categories of portfolios. On the top right, we have an overview, and below that, there's the list of the different portfolios. And on the bottom, a portfolio overview of different categories of portfolios. Another page is the allocation page, where we can have an overview of the portfolios according to different categories. For example, here, a user filtered the portfolios for the country category, and we can then easily see the setup of the whole portfolio that is under management. So the last slide I have for you today is another view of the allocation page. Here, a user used the drop-down at the top to filter for a specific mandate, and then view this mandate according to its category. We can see here that we have basically bonds, equity, and fund in this mandate. Yeah, this wraps up my part of this webinar. Thank you again, and I'm handing over back to Victor.
So, well, thank you, Alex and Tobias, for your presentation. Now I'm going to do the wrap-up and conclusions. Basically, as we've seen, Databricks has many advantages. One of them is basically that it's a multi-cloud data platform that can be used in any of the public clouds providers, which is AWS, Azure, and Google Cloud. It provides a unified governance with the Unity catalog, and they also provide an extraordinary query engine based on Spark. They also provide this powerful Lakehouse experience with the AI integration, creating this data intelligence platform. And they also provide this holistic MLOps experience with their native integration of MLflow. Also, regarding what synvert can provide you in your journey to Databricks, basically we have multiple accelerators that can reduce the time to delivery in Databricks. We also are an experienced partners with years of experience and customer success stories. And we have specialized teams in every industry that can help you understand the specific use case that you have. So after 2 years, we have also concluded this series with all the content that we wanted to cover for creating our Lakehouse data platform in the cloud. Many of them have evolved since we did the webinar. For example, we explained Azure Synapse for Azure, but now their flagship is Microsoft Fabric. So as you can see, the data environment is in constant change and sometimes can be difficult to be up to date. But don't worry, because you can reach us for assistance, as we have a wide team of experts in each technology that can guide you in your journey to the cloud. So thank you everyone for attending. Remember that you have the rest of the webinars available in our YouTube channel, and we hope that you enjoyed this series. Thank you so much.